So good morning. We will take uh, take uh, take up our remaining questions in this coming 2 hours. So what I plan to do is I will take around 40-45 minutes. Then I'll give you a break, and then we will again resume the class, and then we will wind up at 1:30. എനിക്ക് അവേഴ്സ് ഇല്ലാത്തത് കൊണ്ട് ഇത് പ്രോബ്ലി ഇത് ലാസ്റ്റ് 2 hours ആയിരിക്കും ഇന്നും നാളെ ആയിട്ടുള്ളത്. സോ അതുകൊണ്ട് ഞാൻ മാക്സിമം കവർ ചെയ്യാൻ വേണ്ടിയിട്ടാണ് ക്ലാസ് മിസ്സാകാതെ സ്കിപ്പ് ആകാതെ ചെയ്യുന്നത്. സോ കൈൻഡ്ലി കോപ്പറേറ്റ്. ദോസ് ഹു ആർ സീയിങ് ഇറ്റ് ഇൻ യൂട്യൂബ്, you can give your attendance in the comment section or in the live chat. So live ആയിട്ട് അത് കാണുന്നവർ ലൈവ് ചാറ്റിൽ അറ്റൻഡൻസ് കൊടുക്കാം. അല്ലെങ്കിൽ those who are seeing it later can put their attendance in the comment section. Those who are attending the class online will get the attendance now itself. So that's about the announcement. നമ്മൾ കണ്ടുകൊണ്ടിരുന്നത് we were seeing about FM, AM and FM. We saw about AM modulation, amplitude modulation and frequency modulation. അത് കഴിഞ്ഞതിന് ശേഷം നമ്മൾ we saw about the super heterodyne receiver, that is in the 5th module. So today's class we will continue with the 4th module about FM transmitters and FM receivers. So നമ്മൾ FM-ന്റെ properties നമ്മൾ കണ്ടു. FM-ന്റെ properties കണ്ടതിന് ശേഷം we have to see what are the circuits which are used for producing the FM wave. അങ്ങനെ FM wave പ്രൊഡ്യൂസ് ചെയ്തിട്ടാണ് അതിനെ നമ്മൾ ട്രാൻസ്മിറ്റ് ചെയ്യുന്നത്. അപ്പം FM പ്രൊഡ്യൂസ് ചെയ്യുന്ന സർക്യൂട്ടിനെ നമ്മൾ FM മോഡുലേറ്റർ എന്ന് പറയും. അതിന് നമുക്ക് പിന്നെ നമ്മൾ അതിന് പവർ ആംപ്ലിഫൈ ചെയ്തിട്ട് നമുക്ക് അതിനെ ട്രാൻസ്മിറ്റ് ചെയ്യണം. അപ്പൊ ആ FM മോഡുലേറ്ററും പവർ ആംപ്ലിഫയേഴ്സും എല്ലാം കൂടെ വരുന്നതിനെയാണ് നമ്മൾ FM ട്രാൻസ്മിറ്റർ എന്ന് പറയുന്നത്. So it will be transmitted through the antenna. It will be traveling through this environment. അവസാനം ഒരു റിസീവർ ഉണ്ടായിരിക്കും. അപ്പൊ ആ റിസീവർ ആന്റിനയിൽ it will be received at the receiving antenna, and then it will be demodulated, and you will be getting our signal back, and then might be up to increase the strength of the signal, amplify the signal. So അങ്ങനത്തെ എല്ലാ ബ്ലോക്ക് കൂടെ ചേർന്ന് വരുന്നതിനെയാണ് നമ്മൾ FM റിസീവർ എന്ന് പറയുന്നത്. The circuit which does the demodulation, that is called FM demodulator. So in the receiver, one of the blocks is FM demodulator. There will be other blocks also in the FM receiver circuit. So ഇതാണ് നമ്മൾ പഠിക്കാനായിട്ട് ഇനിയുള്ള പോർഷൻ. അതിൽ നമുക്ക് പലതരത്തിലുള്ള FM modulators ഉണ്ട്. So there will be different types of FM modulators, and so in FM transmitter, this modulator block will be different. Similarly, FM receivers, there are different types, and we will be seeing the different types of FM receivers. And one of the blocks in the FM receiver is FM demodulator. At the onset, we will study about the two types of FM. FM രണ്ട് തരത്തിലുണ്ട്. One is called wideband FM, another is called narrowband FM. So initially, we will see this narrowband FM and wideband FM. A little bit of mathematics is there to understand what is the difference between wideband FM and narrowband FM. And then we will be obviously going to the circuits. So this is what I'm planning to cover in the coming sessions. Okay, let me share my screen. Do you have anything to clarify? Any clarifications on that? Shall I proceed? At least in the chat box, will you reply that I'm better alone. Are you able to see my screen?
Yes, sir.
Okay, thank you. Okay, let me just verify. Right. So, today's class we are going to see about the two types of FM. One is called narrowband FM, and the other one is called wideband. Sometimes you put a shape. So there are two types of frequency modulation. One is called narrowband FM, and other is called wideband FM. So let's see what is narrowband FM. So narrowband FM means that the FM modulated wave has a narrow bandwidth. FM modulated signal has a narrow bandwidth. We saw the concept of bandwidth earlier. Hope you remember that. That is the frequencies, the total frequencies which are required for us to transmit. നമുക്ക് ട്രാൻസ്മിഷൻ നമ്മൾ ഉപയോഗിക്കുമ്പോൾ നമുക്ക് എത്ര ഫ്രീക്വൻസീസ് നമുക്ക് വേണ്ടി വരും. Maybe this is 0. Maybe for transmitting this FM signal, you require some range of frequencies. This axis is frequency, and this is amplitude. So you require some frequencies from F1 to F2. And this is what we call it as bandwidth. This is our bandwidth. The total range of frequencies we require. And hope you remember, we have defined the bandwidth as equal to F2 minus F1. So it is the highest frequency minus the lowest frequency which we use for transmission. So അവിടെ നമുക്ക് narrowband FM we require a narrow bandwidth for the data transmission. So that is the meaning of a narrowband FM. Now let us see how we will come to this narrowband FM. So we will consider the derivation, a small derivation. What is the assumption in the narrowband? So let us consider we are considering a single tone modulation. That means, hope you remember what do you mean by single tone means there's only one frequency. Message in the other frequency or and that is M of t is equal to AM cos omega mt. Or simply we can write AM cos omega m means it is 2 pi fm into t. So we have a message in the other. This is our message which is having only a single frequency. Okay. Now we will write about the instantaneous frequency because we know that in FM the instantaneous frequency is changed according with the message signal, amplitude of the message signal. So our instantaneous frequency means we write Fi of t, which is equal to Fc, that is the frequency of the carrier, plus there is a constant Kf into we have Am cos 2 pi FMT, our message signal. And we can write this is equal to Fc plus delta F into cos 2 pi FM into T. So what is Kf into AM? അതിനെയാണ് നമ്മൾ delta F എന്ന് പറയുന്നത്. So here delta F is equal to Kf into AM, and this is what we call it as the frequency deviation. So this is our instantaneous frequency. So what is the phase? Let us see. Phase, that is theta I of t. This is, we know, 2 pi taken from 0 to from 0 to t Fi. I'm just changing the variable. So this is equal to 2 pi. Earlier we wrote what is Fi. So 0 to t, Fi is Fc plus delta F cos 2 pi FMT. Then we have, so now one more change is there. It is Fm into tau because we have changed the variable. Into we have d tau. Sorry, this is d tau. I will correct it. It is cos 2 pi Fm tau into d tau. So we have to integrate this. So when you integrate this, this becomes 2 pi Fc is a constant. When you integrate now, it becomes tau. This is total integration. So it becomes tau. And when we substitute the limits from 0 to t, it becomes Fct. Plus, here we have delta F is a constant. We have to integrate cos 2 pi Fc. So cos 2 pi Fc integrate we get sine 2 pi Fm. Okay, let us do step by step. Fm into tau Then we will have, we are doing the integration. So divided by 2 pi fm. And then we are going to substitute the limits 0 to t. So when you, so we are going to substitute for tau. So it becomes delta f into sine 2 pi fm t minus delta f sine 2 pi fm into 0. So it is sine 0, sine 0 is 0. So that term will get entirely cancelled. So you have total, you have 2 pi fct plus, anyway, we have delta f by 2 pi fm into sine 2 pi fm into t. This is their common. Now 2 pi is common. So what you can do is you can take 2 pi outside. So it becomes no. Okay, sorry. We already have 2 pi common outside. Yeah. If I 2 pi common under. So this is 2 pi. Okay. So we can take 2 pi f fct plus 2 pi open up, it becomes delta f pi fn into sine 2 pi fn into t. So you get the phase like this. Now, what is this term? We have already written about this term, delta f by fm, what we call it as beta. It is the phase deviation. It is the phase deviation. So we have, I'll write it here again. We have phase deviation beta, which is equal to delta f by fm. And fm is called P. Okay. So what happens to the FM wave? Let us see what happens to the FM wave. So FM wave is S of t, which is AC cos, remember, 2 pi fct plus beta sine 2 pi fm into t. This is what we just wrote, phase. നമ്മൾ phase എന്ന് പറഞ്ഞ് നമ്മൾ നേരത്തെ എഴുതിയതാണ് ഈ കാണിച്ചിരിക്കുന്നത് 2 pi fct plus beta into sine 2 pi fmt. So അതാണ് നമ്മുടെ FM wave form എന്ന് പറയുന്നത്. So if you expand it, what you can say, it's a cos A plus B എന്നുള്ളൊരു ഫോർമാറ്റിലാണ്. So you can write A cos 2 pi fct cos A cos B. So it is cos B എന്ന് പറയുന്നത് beta times FM into T minus AC sine 2 pi fct into sine of beta sine of 2 pi Fm into t. I hope this is clear. See, either this is of the form cos A plus B. So remember cos A plus B in the is equal to, this is very known, cos A, cos B minus sin A, sin B. And remember, ഇവിടെ B എന്ന് പറയുന്നത് it is beta sin 2 pi fm into t. അതുകൊണ്ട് നമുക്ക് ഇവിടെ കിട്ടുന്ന ടേം നോക്കണം, cos of beta into sin. So cos of sin, കോസിന്റെ അകത്തൊരു സൈൻ വാല്യൂ വന്നേക്കും, അതുപോലെ തന്നെ സൈനിന്റെ അകത്ത് ഒരു സൈൻ വാല്യൂ. So this is our term that we get. Okay. Now we are considering narrow band. Right? So to be narrow band, beta is small. Beta should be small. So if beta is small, we are comparing it with 1 radian. Now value it is beta value is small compared to 1 radian. Then what we write is cos of beta into sin 2 pi fmt. This is approximately equal to 1. And sin of beta sin 2 pi fm into t, this is approximately beta into sin of 2 pi fm into t. This is an approximation. So ഈ approximation ആണ് നമ്മൾ narrow band fm ന്റെ അകത്ത് നമ്മൾ അപ്ലൈ ചെയ്യുന്നത്. So our equation becomes, so hence for narrowband FM, we have S of t is equal to AC. So we are going to approximate it. So cos of beta sin 2 pi ft is 1. So the entire equation becomes cos 2 pi fct. Should I write the previous step also? This is our equation. AC cos 2 pi fct into cos of beta. So okay, let me write it in my. Thank you. Narrowband, we get S of t is equal to, remember our equation, AC cos 2 pi fct. The next term becomes 1, so into 1 minus, then we have AC sin 2 pi fct, and the second term becomes into beta sin of 2 pi fm into t. So it becomes like AC cos 2 pi fct minus beta into AC sin 2 pi fct into sin 2 pi fm into t. So we get two terms. One is a cos term and the other is a product of sine into sine. അപ്പോൾ ഇതാണ് നമുക്ക് കിട്ടുന്നതായിട്ടുള്ള അപ്രോക്സിമേഷൻ. ഈ ഒരു അപ്രോക്സിമേഷൻ ആണ് നമ്മൾ നാരോ ബാൻഡ് എഫ് എമ്മിനകത്ത് നമ്മൾ ചെയ്യുന്നത്. So remember, for narrowband FM, the approximation is this. This you have to remember. This is that is the only assumption in the narrowband. ഇങ്ങനെ ഇത് നമ്മൾ ചെയ്യുന്നത് കൊണ്ടാണ് നമുക്ക് നാരോ ബാൻഡ് കിട്ടുന്നത്. And okay, we will see what is the envelope. അപ്പോൾ നമുക്ക് ഇവിടെ കാണാൻ പറ്റുന്നത് സാധാരണ എഫ് എമ്മിൻ്റെ അത് നോർമൽ എഫ് എം we find that the amplitude is constant. Amplitude constant ആയിട്ടിരിക്കും. നമ്മൾ നേരത്തെ വരച്ചതാണ് ഫ്രീക്വൻസി കൂട്. ഫ്രീക്വൻസി കൂടി പിന്നെ ഫ്രീക്വൻസി കുറയും. ബട്ട് ദിസ് ആംപ്ലിറ്റ്യൂഡ് നോ that will be always a constant for the normal FM wave. But here what we find is for narrow band FM, the amplitude is not constant. Or we can say that its envelope is not a straight line. It is not a constant. It changes. So we will write the equation for the envelope. So അതുകൊണ്ടാണ് envelope significance വരുന്നത്. അല്ലെങ്കിൽ envelope ഒരു constant ആയിരിക്കും. ഇവിടെ അത് constant അല്ല narrow band. We find that it is okay. I will do one more simplification and then come. Let us write the equation for the narrow band. Is AC cos 2 pi fct minus beta into sine 2 pi fct into sine 2 pi fm into t. So this is of the form sine A sine B. So we can apply our substitution. What is sine A sine B? It is equal to cos A plus B minus no. Minus cos A plus B. So what is cos A minus B? It is cos A cos B plus sin A sin B minus cos A plus B is again cos A cos B plus sin A sin B. So a negative sign വരുമ്പോൾ നമുക്ക് cos terms cancel ആയി പോകും. Both the terms become zero. So it is actually 1/2 times. So we can apply this equation in the previous one. We are applying this trigonometric property. What will we get? We get S of t is equal to AC cos 2 pi fct minus beta into, instead of sin A sin B, I have 1 by 2 times cos, see, A minus B. So it is 2 pi. We will do always Fc minus Fm because carrier frequency is always greater than the mod message frequency. So 1 by 2 cos 2 pi Fc minus Fm into T minus, okay, this is constant. 1 by 2 is common for everyone. So let me write here beta by 2. I will remove this. Minus, I have cos 2 pi A plus B. So Fc plus Fm into T. So maybe, so bracket here is there. Here also there is a bracket. And then I have this square. So it is AC cos 2 pi FCT minus beta by 2 into cos 2 pi FC minus FM into T minus cos 2 pi FC plus FM into T. So I'm applying this trigonometric property. So what is the envelope? So envelope of the narrow band FM, shall I write A of T? It is just the amplitude square. So first we will have AC into 1 plus modulus of cos 2 pi FCTs. Look into the previous equation. Modulus of AC cos 2 pi FCT, cos and the modulus value will be 1. Maximum value will be 1. So we have AC one plus, then we have 1 by 2 times the modulus value of the other term. So it will be beta square sine square 2 pi Fm into T. So this is the envelope. Maximum value of the envelope. So it will happen when sine equal to 1, sine theta equal to 1. So this is equal to AC into 1 plus 1 by 2 beta square. What will be the minimum value of envelope? Minimum value we will get when sine theta is equal to 0. So it is when sine theta equal to 0, the second term, the entire second term becomes 0. So it will be equal to AC. So what is the ratio of maximum value to minimum value? It is equal to the first term divided by the second term. So it will be equal to 1 plus 1 by 2 beta square. And what is the power? What is the power of the narrow band? You can see the power of the narrow band is, you have to take the average value of each terms, right? So AC cos 2 pi fc half average value എന്ന് പറയുന്നത് 1 by 2 times ac square. Plus second term എന്ന് പറയുന്നത് it is 1 by 2 beta cos 2 pi fc plus fm into t. So അതിന്റെ average value എന്ന് പറയുന്നത് it is half beta ac whole square. Second terമിന്റെയും magnitude same തന്നെയാണ്. So beta ac the whole square. So in total we will have 1 by 2. എല്ലാത്തിലും ac square ഉണ്ട്. So we will take outside. So 1 plus. Then you have 1 by 4. Sorry for the mistake. Half times the so 1 by 2 is outside. So 1 by 2 beta square ac square plus 1 by 2 beta square ac square. So it will be 1 by 2 plus 1 by 2 is 1 beta times ac square. So it will be 1 by 2 beta square. I think little confused. The 1 by 2 പുറത്തെടുക്കുന്നുണ്ട്. 1 by 2 ac square എന്ന് പറയുന്നുണ്ട്. Now what is 1 by 2 ac square? What is the power of the carrier? Power of the carrier is 1 by 2 ac square. So power, average power by the carrier power, if you take note, you can find that this is equal to 1 by beta square. So these are two important results that is coming when we have this narrowband FM. Narrowband FM in the average power by carrier power, previous data, we are taking the ratio of the maximum value by minimum value. These two terms we can see this. Is it clear? Any doubts you have? So narrowband FM the spectrum how will the spectrum be? If you take the spectrum, it will have three components. One is FC, then you have FC minus FM. So this is FC plus FM, and this value will be FC minus. So this is somewhat like our double sideband normal AM waveform. So, but it is we are deriving it from the envelope envelope will be somewhat similar to the double sideband AM signal. Double sides of the AM signal but it is frequency modulated. Remember, it is having frequency modulation, but its envelope will not be a constant, it will be varying. So that is one of the difference between wideband FM and the narrowband FM. In narrowband FM, the bandwidth is small. FM bandwidth is made narrow. But in wideband, narrowband, the bandwidth is made small. In wideband, the bandwidth will be large. Then second comparison you can say is, in narrowband FM, the envelope is not constant. It is having some changes, and that change will be somewhat similar to the double sideband AM signal. But in the wideband FM, the amplitude will be always constant. it will not vary. So this is about the narrowband FM. And always narrowband FM will have some distortion. But in wideband FM, there will be no distortion. So that is the comparison between narrowband FM and the wideband FM. So let me just quickly go through wideband FM also, since we have studied it, or we have already discussed that, but we will just go through the definitions about wideband FM. Wideband FM is actually our normal FM. Normal FM signal is what we call it as the, we don't go for that approximation. So S of t is equal to AC cos 2 pi FCT plus beta into sine 2 pi FM. ഇത് നമ്മൾ cos A cos B apply ചെയ്തിട്ട് expand ചെയ്തിട്ട് ബീറ്റയെ നമ്മൾ അപ്രോക്സിമേറ്റ് ചെയ്യും നാരോ ബാൻഡ് എഫിന്റെ. വൈഡ് ബാൻഡ് എഫിന്റെ നമ്മൾ അങ്ങനെ ഒരു അപ്രോക്സിമേഷൻ നമ്മൾ പോകുന്നേ ഇല്ല. വി ആർ നോട്ട് ഗോയിങ് ഫോർ ദാറ്റ് അപ്രോക്സിമേഷൻ. സോ ലെറ്റ് മീ explain that to you 1 minute. So, ഇങ്ങനെ ഒരു ടേം വരുമ്പോൾ wideband FM അകത്ത് what we do, this is the normal FM. So we have a term called, what happens when we expand this now, we will have AC cos 2 pi FCT cos A into cos B. So B is our big term, beta sine 2 pi FM into T. So cos A cos B minus, again AC is constant, so AC is common in both. So we have 2 pi FCT into sine of beta sine 2 pi FM. So ഇവിടെ നമുക്ക് we have this terms. How to write these terms? We are using Bessel functions. We have to find the values now, so we use Bessel functions. So let me see 1 minute. Bessel functions. So I will write the nth order Bessel function. We will write it as J n beta into AC cos omega C plus or minus so നമ്മൾ നേരത്തെ ചെയ്തപ്പോൾ നമ്മൾ കണ്ടായിരുന്നു, we have terms like this. So we use Bessel functions of nth order. This is the nth order Bessel function. Should I write it one more time? So ഇങ്ങനത്തെ ടേംസിൽ നമ്മൾ എഴുതും. ഇതാണ് നമ്മുടെ ബെസൽ ഫംഗ്ഷൻ. അപ്പോൾ ഇത് നമുക്ക് മേളത്തെ ഇക്വേഷൻ നമുക്ക് എക്സ്പാൻഡ് ചെയ്യുമ്പോൾ വിൽ ഗെറ്റ് സോ മെനി ടേംസ് ലൈക്ക് ദിസ്. ആൻഡ് റിമെമ്പർ ദി സമ്മേഷൻ ഇസ് ഫ്രം 0 to infinity. So that is why I told you, there will be infinite number of sidebands. അപ്പോൾ ഇതിന്റെ സ്പെക്ട്രം ഇതിന്റെ അകത്ത് എടുക്കുമ്പോൾ എന്നിന്റെ വാല്യൂ it will start from 0, 1, 2, etc. to infinity. So when it is 0, you have this pure AC cos omega ct. When it is 1, we have AC cos omega c plus omega m into t, and we have AC cos omega c minus omega m into t. When there is 2, we have AC cos omega c plus 2 omega mt and omega c minus 2 omega mt. അപ്പോൾ നമ്മൾ അതിന്റെ സ്പെക്ട്രം നമ്മൾ വരയ്ക്കുമ്പോൾ see, we have a lot of components. We have one at omega c, then we have omega c minus omega c plus omega m. So let me draw it in a new. So അതിന്റെ components നമ്മൾ വരയ്ക്കുമ്പോൾ the spectrum വരയ്ക്കുമ്പോൾ we have one at omega c, then we will have at omega c plus omega m, then we will have at omega c plus 2 omega m, then we will have at omega c plus 3 omega m. So this is omega. And then we have so many components. And here also we have at omega c minus omega m. Then we will have at omega c minus 2 omega m. Then we have omega c minus 3 omega m and so on. കാരണം ഇതെല്ലാം കൂടെ ആഡ് ചെയ്താലേ നമുക്ക് ആ ഒറിജിനൽ ഇക്വേഷൻ തിരിച്ചു കിട്ടും. So the spectrum will be like infinite. Analysis നമ്മൾ ചെയ്യുമ്പോൾ spectrum we can find that it is having infinite number of components, which I told you, which we cannot do. So what we do is we will take a limited number of bandwidth. Adana given by the Carlson's rule. We saw the bandwidth of the FM. It's defined by Carlson's rule. We have taken it last class. Okay. So this is about narrowband FM and wideband FM. അത് കമ്പാരിറ്റീവ് ആയിട്ട് പഠിക്കാൻ പറ്റാം. അപ്പോൾ narrowband FM അത് രണ്ട് കമ്പോണൻസ് നമുക്കുള്ളൂ, omega c minus omega m and omega c plus omega m. But in wideband FM we have infinite number of components. Theoretically we have infinite number of components. Okay. So we will wind up this session here. We will go for a break. Now on my watch it is 12:36. So we will have a 10 minutes break, and we will start at maybe 12:45. So I will take one more 45 minutes class, and then we will wind up. So if you have any doubts, you can ask. I hope you don't have any doubts. So wind up PM. We will meet after 10 minutes. That is 12:47.
Yes, sir.
Thank you.